Hello, everyone. Welcome to one more episode of our podcast, Real AI Now. Today, we have a special guest, Lukasz Lewandowski. Hi, Lukasz. Thank you for
Hi, Paul.
joining
How are
us.
you?
Very good, thank you. I hope you're doing well too. I hear you are in Greece, so this is
Starting my summer, yes.
very jealous of that. Lukasz, thank you for joining. Thank you for joining us. Lukasz is leading a unit, data mesh platform unit at Swiss Re, a global reinsurance company, and he has a lot of experience in this field, at least a decade, probably more, 15 years of experience in dealing with data, these topics of data in enterprise and financial services. So very happy to have you here today, Lukasz. I'll fire right up with a question and with a hot topic, which is AI and machine learning. How much is that real in insurance and how much is that hype? How would you say in terms of percentage?
Good question. So first, thanks for having me. I'm glad to be here. It's a loaded question, right? It's one of those problems where I think we talk a lot about advanced technologies, and especially in the big old financial industry that tends to be very stable and not necessarily has the label of the most innovative. How much does it really help in our daily business would probably be the way to answer that. Yeah. And I think realistically, we are still quite early on the journey, right? We are not a company who is AI driven, right? Or even fully digitized, right? Some of our processes are just not digitized, right? To the point where we can start working on automation. So I think there is a lot of hype, but there is an element that we should not forget, which is that some of the applications of AI technologies, or maybe more specifically ML, or even more specifically, applied statistics, can very quickly change the results of our business because at the size at which we operate, right, even one successful implementation can have a very material impact, right? Which is why a lot of work and a lot of scrutiny is kind of put into where we can apply new technologies.
So could you give us an example of what you just said? They can change the way we do business. How can that change?
Yeah, I think I can. So in the insurance reinsurance world that I've been working very closely with for the last 10 years, one of the big topics has always been dynamic pricing, right? So all kinds of strategies of quoting specifically for that circumstance, for that specific risk, right, of that specific client and that specific point in time. Because the insurance industry, for the better and for the worse, tends to be very kind of generalist, right? It's about high level assessments, right? Multiple people kind of chipping into the same risk pool, right? You actually don't want to be too nuanced, right? And most of the time, it's our business is not the same as Netflix recommendations, right?
Yeah.
But there is a lot of opportunity to assess risk better, and especially in the areas where where our simplified approach underestimates certain risks, right? Or does not take all the risk factors into account because we simply just did not get all the information that we happen to have across the company into that decision, right? We do not feed all the available information into the decision. And this is where I think the opportunity is very big, right? And just being more aware, right, of the description of the risks that we try to underwrite.
Okay. Sounds good. So I would like to stay again in an example, if you allow me. So, for example, what is something that you could not do before, right? Before AI, that you could do now, that in insurance with AI, right? What comes to mind? So, like business models, so new business, for example, that's one thing that comes to mind. And if you could give us an example of that, or something that we can do now because of AI, or we could do if we actually implemented it, like that becomes much, much better, like an order of magnitude better because we use AI now?
So I'll go back to first to things where we can improve existing, I think, processes and existing business with AI. Being able to process and automatically take into account information that comes from unstructured sources. You know, in our specific business, we talk a lot about insurance of complex risks, right? I mean, imagine insuring a factory, right, or a rocket launch, right, or placing 20 satellites in orbit, right, in one go, and so on. These are all relatively complex problems, and we usually get a description of these risks in very different types of formats, right? There is no XML standard for, you know, how you describe a rocket launch, right? It's a pile of documents, right? And obviously today, assessment of such risks is, you know, very labor intensive, or because it is very labor intensive, it sometimes tends to be very superficial, right? I mean, so you have to make that choice, right? I mean, do you pay an expert engineer, right? A risk engineer to do this assessment, or do you instead just, you know, take some sort of a averaged, you know, risk factor or set of risk factors and just underwrite based on that? Or
sorry for interrupting, or you hire an external company to
give you right?
to give you a report, but then you still need to underwrite it yourself. So you need to take that report and then.
That's right. So you have a couple of these phenomena here, right? That you have a lot of unstructured information that you're facing. So you have to pay somebody to go through that. You have to trust that entity, right? Whether it's your own employee or an external company. And then ultimately you have to decide, you know, how much you want to spend on this. And obviously, in the case of very large risks where we potentially, you know, have big exposure and things like this, you can make an investment, right? And then just, you know, to do this manually. But even then, how do you benchmark, right, between the different manual approaches, right? Like you bringing automation, right, is not just about pure operational efficiency. It's also about standardization to some extent, right? To be able to benchmark, to be able to see which approach works better, which one doesn't, right? It's especially when the processes, you know, achieve a certain volume, right? You need a level of standardization, right? So we strongly believe that many of these modern technologies help, right, in going exactly in that direction. And I think there is a debate, right, how much you should actually, you know, automate, and at one point maybe, you know, you start losing certain finesse, right, from the assessment of risk. But that's definitely where the industry is going. It's definitely where we try to apply, right, these approaches.
Okay, that makes a lot of sense. So analyzing unstructured data, especially text, but also pictures and all kinds of videos and all kinds of things. We recently actually are working on something like that with one of our customers, and it's about risk reports in engineering projects, or either objects or they already exist or they are being built. It's a B2B case, so insurance company insures either the industry or the company that is building some new object, and these reports are quite extensive. They can be hundreds of pages, sometimes 1,000 pages, depending on the size of the project. And there are tools, but I feel that there is a lot to do, and especially with with these emerging new large transformer models, and we can talk about that later a bit. This could be a game changer, and this could actually bring the quality and the standardization of that type of analysis to the next level. I agree. I think it's really changes things, right? It's an order of magnitude of improvement that can be achieved, and this is quite powerful. So taking a step back, you're a data guy, right? And this stuff is about data. So there's no AI without data. And companies need to build their data foundation. And they need to have a data strategy. They need to think data. And in order to be able to make data-driven decisions, whether they are done then by AI, taken by AI, or by people, you still need data in both cases. So what are the do's and don'ts? So if we start from a company like yours, a large company, a global company, what are the do's and don'ts in a data strategy that come to mind?
It's a good point. So before we get to and intelligence is always needed to make decisions, right? And this can either be human intelligence, right? Wet we're making some of those calls, right? We do that today. It can also be AI, but you're right. I mean, first you have to make sure that the process, right, to feed the right information exists, right, and it's a reliable process. And for a lot of that, to build a reliable process that pipelines data through an organization, you don't need AI, right? These are things that can be achieved with technologies that we've had for 20, 25 years. More recently, and I think with the advent of clouds, more distributed computing, right, less dogmatic, I think, approach to data management and so on, it's easier to build bigger and more interoperable data landscapes. Companies like in the financial industry definitely suffer from a lot of legacy, right? And then getting out of that legacy that is very tied to proprietary data management methods, right, is a journey, right? And I sometimes feel like it's a misnomer to say that company has a cloud strategy, or like especially one like ours, right? I think ultimately the company has or should have a data strategy, and then implementation of the data strategy, whether it is by means of cloud services from big vendors, right, or open source or something like that, right? That's a little bit secondary. And I think in many discussions have been the carriage is a little bit in front of the horse, right? So you do have to have a data strategy first. And I cannot necessarily speak for the whole industry, but I can share some of the experiences and my own experiences, I guess, my opinions, right, on that. One of the things that one absolutely needs for a consistent data strategy is, first of all, realization that this is even a problem. I don't necessarily believe that the business functions, right, in this industry fully understand or realize how important the flow of information truly is, right? The technical flow of information, right? Not just the logical flow of information. And maybe 15, 20 years ago, it wasn't as important. The amount of information was smaller, right? The breadth of information was not there, and so on. But at this point, we're really pushing a lot of information about customers' behavior, in our case, risk, right? Location of the risk, history of the risk, etc. You have to have an extremely well-oiled machinery to move that thing around from one function to another in the business, in order to even think, right, of bringing truly transformative automation to it in the second or third step. So what are the do's, right? Coming back directly to your question, like one of the things is definitely about having, if possible, a single strategy, or if it's not a single strategy, then I'd have a modular strategy. And what I mean by that is, if you have a big group, right, a conglomerate of some sort, or at least a bigger group that has multiple business units, you probably want to have at least a group level strategy that is consistent, that defines the interfaces between your units, right? And not necessarily impose how they should build their own data strategies inside, but impose what is the connecting tissue between them, right? And that includes both logical prescriptions, right? So whether it is the logical exchange standards, right, between the units, ownership standards and things like that, SLAs, right, that the different units offer to each other, but potentially also technical standards, right? And be quite I would say probably quite dogmatic on that, right? The choosing the right or wrong technology in 2023 is not a particularly big risk, because a lot of the technologies in that space are somehow derivative of some open source standards that have emerged over the last years, right? We have way less proprietary technology in information management and information exchange than we used to have. So whether you choose a particular implementation of Spark, SQL, Python, or reporting stack and so on, doesn't actually matter all that much. So, but you can make a decision as a company to go with one particular approach and just remove all the effort from maintaining multiple extremely similar software stacks, right, across the company, because that's where I think that's my personal belief is that there is so much similarity between the different types of platforms, and choosing the best one doesn't change much, right? Choosing one and sticking to it and not having to deal with continuous questioning of your choices or continuous interruptions from being in between two technology stacks, right? That is something that I personally find very valuable. And specifically in my job, where we look at these data mesh topics, right, we try to be extremely consistent. So that's a little bit of the on the do's, right, what to emphasize. What one should not do is one should first and foremost not turn it into a crusade, right? And what I mean by that is these types of transformations absolutely must not be technology or IT function driven, right? They have to be very highly correlated with what your business functions want to achieve, but also what they can assess as progress. So, taking your organization for a 5-year program and telling everyone that you need to wait the first 5 years before you can actually see the results of it, right, is not a particularly good proposition. And to be honest, it is possible to run such transformation and build these data pipelines that connect your whole company in a way that in a piecemeal way, right? So bit by bit, right? Start by connecting two big units and show how to sort out their own problems inside, right? Then add a third one, then add the fourth one, and then the fifth one, then the sixth one, and volunteer to be next by themselves, right? That's a little bit the kind of the mindset I'm talking about.
Okay.
So coming back to the don'ts, right? Don't try to make it into a purely technical exercise, and I think don't fixate on technology in general either, right? Don't experiment maybe too much. There's probably one other thing that I would say, like, you don't always have to be on the latest and the greatest, that has just been released in some open source channel, which technologists sometimes tend to do, right? I mean, it's probably okay to be 1 or 2 years behind, on what the absolute cutting edge is,
right?
At least for a company, the size of mine.
Yeah. Okay. I mean, I picked up on a few things. So one of them is strategy, and so I have 2 follow-up questions based on what you said. One is about strategy, the other one is about more specific, which is usually a topic, and about selecting a technology or a platform. But let's start with the strategy. You said we need a strategy. So first, realizing you actually need a strategy, that's the first step. That you need to get your data sorted out. And then once you do that, you need to develop a data strategy. So what is a data strategy? What are the pillars of a data strategy? What does that include? You mentioned a few things like there, but could we dig a bit deeper on that? Because this is a topic.
I'll start with something that we might sometimes forget and might sometimes be obvious to people who kind of spend their days, right, in their whole life in the topic. But
yeah,
there is a certain underlying assumption, right? The assumption is that if all the data of a company is available at any step of the decision-making process or decision support process, we will be able to make a decision that generates a better business outcome. So one of the objectives of the strategy is to to increase the data availability, right? The recency of the information, the discoverability of the information, right? Readiness of information at any step of the process. Right, that's a little bit how I can think about that. Maybe not many people think about it like this in general terms, but that's ultimately what it boils down to, right? Like when you're in a point A and you want to support the decision taken in A, nothing should stop you from utilizing all the information that the company has, or all the information that is in the outside world somewhere that can support it, right? And like any friction to provide all the information that needed in this point A, right, is wrong, right? So the data strategy should essentially answer a question how to eliminate all the friction, right, at the lowest possible cost, right? To date, present cost, and future cost.
Right. Yeah, I completely agree with that. I mean, in other words, this could be like seen from the perspective of an executive. When you ask a question about the business, you need to have the answer at the tip of your fingers, right? And now this is the ideal situation, and you can only do that if you have the data at the tip of your fingers. If you have the data right there. Now, even in my company, which is a 50 people company, we don't have a data strategy, right? So we are probably too small yet, but still, as the CEO of my small company, I struggle sometimes with questions. I ask a question about financials, and I don't have it immediately. Somebody in the team needs to go and work for a day or two in order to answer that question for me, right? And so, if you multiply this by 100 or 1,000, then you have a problem, right? If you cannot, because the problem becomes so much bigger, such more complex. So I can completely relate. Even myself in my small company, and I can see that medium-sized companies of 500, 1,000 people, if they don't get that data right, they also have the same challenge, right? And they're much slower. Instead of getting the P&L spreadsheet in a day, they get it in a week, maybe, or 2 weeks, right? In order to get an the up-to-date numbers about the financials, for example. And this is, so I completely relate to that. So the goal, you talked about the goal of a strategy. Now meaning that, let's say I don't have a data strategy now. I'm at the point A where I don't have the data, the information ready. And now I want to move from A to B, and B is point where I have that, what you mentioned. So and I would say the strategy is a plan how to take you from A to B. What are the things that are part of that? How do we build a strategy that takes a company from that point A to that point B?
So I'm not sure whether I can directly answer how to build a strategy. I think that can be, the process of actually reaching the right conclusions, right, and putting the plan in place is something that can actually depend on the organization. Yeah. What I can probably say is what it is that leads you, more conceptually, right, to those outcomes. Like, so how an execution of such a strategy normally works. So if we assume, right, that the generic data strategy is about liberating the data, making it complete, and making it accessible, right, to the best level possible for any decision support process or any decision support point, maybe more specifically, right, for any decision point in your in many of your business processes, right. Then basically, if you start from there, kind of work your way backwards, right? There are a couple of questions that one can immediately ask and start finding answers. So, like, the first one will be, if I'm in a point, first of all, how many decision points there are in the company that are important enough to be supported by a larger strategic effort, right? In a company like mine, that deals with underwriting risk, right, for insurance purposes. Obviously, the underwriting decision, right, or decisions, right, are one such thing. Capital allocation decisions, right, are another. Cash management, asset management, right? Like, so there is going to be a couple of classes of decisions that are all potentially very data intensive if you want to make them highly objective, right? And that is what you tend to want to do, right? You want to make them very objective and therefore data driven. And that would really be the first step, right? Defining what it is that you really want to address, right? And there's more than one class of problems, right? And each class of problems tends to require a different data universe to support the decisions, right? So that will be essentially your second step. What are these data universes that you need to have, right? What are the properties of those data universes, right? Do they need to have information from on the inside or from the outside world? Do they need to be real time? Do they need to be daily, weekly, annually refreshed, right? There are different kinds of information. Like you don't need to refresh your earthquake models every day, right? For instance, right? Like that's something that literally can be refreshed in the geological time scale, right? It's like, it's like I'm joking a little bit, right? But like, no matter what, humans will do to the planet, the frequency of earthquakes is probably not going to change, right? Because of that.
No,
or
not
much, right?
Yeah.
Which is different to rainfall and flooding, right? Where actually you might want to refresh those models, right, based on that information more frequently than you would like to. Right? And the funny thing here is that it's something that we intuitively know, right? But if you put it into a class of, let's say, natural catastrophe phenomena, right, you could theoretically have a single data strategy for that. Not true, right? Very different frequencies, different requirements. So this is where you get, right? You have these clusters of information, then you probably want to group them a little bit and say, okay, what is the actual frequency at which you want to process that information, right? Refresh, etc., etc. And only then, I feel, once you have clusters of topics and information supporting it that you've identified, and you have some clustering based on the frequency of processing, type of processing, where you should start asking yourself technical questions, right? Does it benefit from having a single technology that supports all our very frequent, risk assessment processes, or very infrequent, or those based on, I don't know, satellite images versus those based on, I don't know, chatter that you observe in the news, right? That's also a source of information. And you will end up, by performing that analysis, you will end up realizing that you have a classes of technical but information-centric topics, right? Each of which can be largely worked on independently. And this is where you get to probably one of the first strategic decisions, right? Do you want to attack all these problems all at once and therefore spend, a massive amount of resource in your company? Or do you potentially can attack them sequentially because this is only how much investment you can spend on this, and or how much money you can spend on this every year. I tend not to see that level of sophistication in a lot of the planning, right? Like a lot of work spent on improving such processes is based on more kind of generic strategies. Like, for instance, hey, let's re-platform technology from technology A to B, or let's overhaul all of X, right? And X meaning a certain business process, not an information processing phenomenon, right? So
or even
that's how
even sometimes a process sometimes it's even a department. So let's
exactly
do it for,
right.
Let's do it for this department instead of.
That's right. That's exactly right. And I think that this is exactly where we fundamentally have issues, right, in compartmentalizing it. A data strategy should try and chart a path how to identify and solve information problems,
right,
that may or may not correspond to organizational constructs. And the organizational constructs of both organizations, like teams or departments, but also business processes, right? A business process is very often orthogonal to an information process, right? A business process may push changes to information, right? So like how should I put it? A business process is a residual of information flow, or vice versa, right? An information flow is a residual of a business process, but they are rarely one and the same thing. Especially the more complex the organization, the less these two things align, right? And I think
Indeed.
for a successful data strategy and information strategy, you need to focus on the information.
Yeah. So we talked about decision points or information points where you need information. Then you talked about clusters or clusters of types of data, depending on how frequently you need them, type of data, what type of data it is. Then you talked about, as a third step, technology. And I have a particular question about technology. But I also have another one about how these processes sometimes take place. So I've seen in the past this starting in the other way. So starting from the technology, for example, and you mentioned they could start from a business process. Let's implement this for this business process, or even for this department. This is one way, and I agree that it might not be the right way. But I've also seen a company shaking hands with a tech vendor and saying, okay, let's take this tech and implement it in the company. And then people start like going around and hunting for a use for the product, right? It's a bit what's happening now with ChatGPT, right? ChatGPT, great tech. How can we use this? It's like you walk around with a hammer, trying to find nails on the wall to hit it with this new hammer. And this also happens with data platforms, right? Is this something that you confirm that happens?
I think so. I'll say the following, maybe. The fact that information problems should not be analyzed in first and foremost technical problems does not mean that they are not technical problems, that they are, right? And technology is important. We should not think that all technology is equal and that it's infinitely fungible, right? Like it is not true, right? There is technology that is better than other, right? They sometimes on the face look the same. But I think in reality, the question is more about what is the change agent driving the organization, right? And here I'm a little bit, exactly. And here I'm a little bit less dogmatic. So I think, in a very mature organization where everybody agrees that, I don't know, that mapping out information flows and improving our processes along the information flow, right, is obvious. Like, I think you can start from there, right? Everybody is quote unquote enlightened, right? And there is very little resistance to that, and you can, constructively, work on implementing, bits and pieces, right, that improve the situation here and there. But you don't always have that luxury, right? Sometimes you have to wave a certain standard in front of everybody, and maybe that standard sometimes is, hey, let's migrate everything to the cloud, right? Or maybe that is, let's use a new database that is going to solve a lot of our problems, because ultimately it's a little bit about a vehicle, right? People have to kind of get on the same bus that starts driving them somewhere. And sometimes, whether this bus is that color, this color, that color, doesn't really make that much of a difference. What is important is that the people who actually, lead that or drive the bus somewhere are aware that the bus itself is not that important, right? But rather the destination. That's a little bit how I would look at that, right? So I don't particularly, how should I put it? I would not stigmatize anybody who tries to, conduct a big transformation by saying we're changing technology, right? There may be very good reasons why in that specific organization, that particular call to action is okay, right? Like, I don't think it's really correct, but academically speaking, but I think it's, as a change management technique, why not?
I mean, and I'd like to get to the point, how do you select the technology? Because I think this is a very interesting point to our audience. But to what you said, I agree with you, right? So I also see as technology being a driver for standardization. and sometimes by using a technology, you need to adopt certain standards and certain ways of working that technology sort of imposes.
That's right.
That create good habits and so it allows you to introduce actually good practices and processes in your company to deal with data and information. So sometimes it's not really a bad idea, just to actually decide for a standard for a tech, and now that's what we use, and we actually migrate everybody or everything as much as we can to one single standard, which is implemented by this technology. It doesn't mean it's the best one. It doesn't mean, but it's a standard. And if you chose your technology well, it's probably a good standard that imposes some good practices. So it's also a way of driving change, right? And so I can see that, right? I can see that this is choose one, right? And then choose one, but be careful and thoughtful in choosing it. Make sure that it implements the right standards. But then sticking to it and sort of enforcing it in a company like yours, where there's a lot of heterogeneous, the landscape is very heterogeneous. This could be very cleansing, let's say, to the company, and I've seen that happening in a positive way, right? I've also seen the things that, okay, sometimes you're trying to shoot a small bee with a cannon. This also happens, but well, that's just the price of having a standard.
Absolutely.
And
I mean, there is
yeah.
I cannot disagree. I think a lot of value comes from, how should I put it? There is more value in synergy, or maybe like this, synergies in being consistent. Consistency brings synergies. Consistency brings economies of scale. I will put it like this. And brings us closer to global optimum, right? Rather than to a local optimum, right? So if you were to maintain a very heterogeneous technology landscape, right, in a large company, you will have a lot of local optimum for sure, right? There will be, team, department, whatever, using the absolutely best technology, right? If they know how to select it, right, they will use the absolutely the best technology to solve their specific problem. But you will never achieve a global optimum for the whole company this way, right? You will always have, 3 reporting stacks and 4 databases and 3, web servers and, 4 clouds and so on, right? Like, I mean, I've seen that, right? I mean, you have seen that, right? That's a relatively common occurrence. But we have also seen technologies that are extremely razor focused on being consistent, right? And there is a strategic penalty that comes with this, but there's also a strategic benefit that eventually materializes, right?
Yeah, there's a lot of efficiency coming from that.
Exactly. But the problem with this is that these strategic benefits materialize over time and are usually not too obvious, right? Like, so there's a little bit of this joke I remember, and it's not really a joke because it's something that I experienced. Like, there was this database administrator in a bank, and he was fantastic, right? And he managed like 30 databases. It was absolutely fantastic, right? He knew everything about each of those databases, and he managed them. And at one point, the CTO said, "Well, why do I need you, right? All my databases are working fine." And yeah, really,
I'm just laughing.
Like, that sounds like a joke, right? But it actually isn't. And this makes you wonder, right? Like, do people actually realize when they achieve a certain benefit, right? That is, so how do you see an opportunity cost, right? That you didn't have to pay, right? Like, it's hard to argue, right? That, hey, had we not seen that, our cost would have been 30% higher, right?
Yeah.
It's very easy to say, please change this. We are going to now remove 20-30% of the cost, right? And obviously, it's an extremely hypothetical exercise. But if you've done the right thing, explaining that we're in a better position than everybody else, for instance, in our industry, right? It's frankly only possible through benchmarking. It's extremely difficult to do, right? So It's easier probably to do for technology companies where maybe they compete outright on a specific technology. I don't know, Android versus iOS, right? Type of competition, right? Or something like that. Like there's making these comparisons is easier, right? There's more direct comparability, right? But whether you compare bank A to bank B and whether their data landscape is better than the others, right? Can be very, very difficult. Which is not to say that the benefits aren't there, right? Like this is what I'm trying to lead to. The benefits are absolutely there, but they may manifest in unexpected ways.
But it's difficult to kind of, I mean, they compare each other with their balance sheets, their whatever, their market, their stock price, and their performance. But then, where does that success come from, and how much of that success is actually due to a good data strategy is hard to measure, right? And it's really difficult to prove that, okay, your data strategy led to this financial business outcome. And so this is
but a certain level of awareness there could potentially surface these phenomena. So you are able to tie the cleanliness of your data and application landscapes to the speed at which you can launch a new product on the market, or a speed at which you can adjust your underwriting strategy globally, or to the
speed at which you can report.
Exactly, right? So
how long does it take to run an audit in your entire company, for example? And
for
financial
instance,
audit, for example. Yeah.
Exactly. Or how quickly can you digitize a business process that never was supported by IT, right? Do you need 6 months for that, or do you need 3 weeks, right? And in my job, right, we do actually measure these things and we do make these comparisons, and we can argue, right, that certain technology choices or certain architectural choices, right, significantly change that outcome, right, or can significantly influence that outcome.
Right. And this is a really cool topic that I just added to our list. How fast can one create a new business product, in this case, let's say in the insurance space, because of the capabilities that, for example, that you built, that company like yours has? And how is that compared to 10 years ago, for example? And this is a great topic. I'd like to talk about tech. This is a tech podcast too. So we were at a very abstract level now, strategic level. Now let's get to the tech, to the cool stuff. Now, how do I choose a tech platform? And what does that tech platform should have? Like we're talking data platform. There are several names for these data platforms today. From data lake to data warehouse to data lake house to data mesh to whatever. What are the components that a data platform needs to have? Let's start from that. Yeah. And how can you how do you choose a good one? Right? Because
good question. Very, very good question. I think the first question is, where do you position a data platform in the bigger tapestry of IT in your company, right? Because that is already not a very obvious. There is no obvious answer to this. There are definitely two big modes in which information flows through a large, at least financial institution, but I guess that it's accurate for a lot of organizations, and most of organizations probably. You have the more kind of operational transactional flow. So think about things that you do hundreds of times a day, right? You serve your clients, you make payments, right? You price goods or services, and so on. And then there is the kind of the bigger, and there's probably a few dozen, maybe a few hundred systems, right, that the larger organization manages in that space, right? Like a bank will have an e-banking portal and a transactional subledger, right, like an account management system, a banking management system, and they will have a general ledger and payment system, and Swift gateways and whatever, right? Like that's this whole space. And that space basically implements a certain set of business processes that are heavily parameterized, right, by some people's decisions, right? So there are strategic decisions that are expressed as parameters into those business processes. So for instance, there is going to be an underwriting ratio or an capital allocation cap or a number of clients limit, right? Or things like this, right? And in order to derive or add or arrive at these parameters, right, you have to do a lot of analysis, right? And this analysis, these analytical processes continue in such an organization as well, but they're somewhat like a second, or yes, the second other big area of activity, right? So one is, running the machines, right, and running the operations, and the second one is analyzing the performance of operations and adjusting the parameters of operations, right? And this is the big analytical space, decision support space.
That get that, so analyzing and changing, so the changes then they go back to the
exactly, right. So in
so
a
you're
way,
talking about transactional and analytical.
That's right.
Parts.
So,
right?
so think of it like this, right? In a maybe sort of simplistic way, the purpose of the analytical space is to parameterize the operational space. Because frankly, otherwise there's no business, right? Like, the analytical space may also produce some interesting facts just, for popular science purposes, right? But that is rather a minor element, right, of activity, right, in a company. Most of it should feed back to some decisions, right, that influence operations, right? At the minimum, it's about, assessing the level of risk, setting the right capital allocation and so on. But in some fine detail, it can even be, individual underwriting thresholds, ratios, right, values, and things like that. And so I tend to think of these two spaces as somewhat separate. And when we talk about what a data platform should entail and what capabilities it should have, I usually think about the analytics space much more than I think about the operational space. And that is just because that is where, my experience has been for a long time. But I think that there is also a good reason to separate these two worlds.
Yeah, and that I was talking about that, right? So well, I mean, when I asked the question about a data platform, I didn't mean the data platform or the technology that supports the day-to-day transactions. I'm not talking about that. I'm talking about the other part, right? The analytics part, the ones that support decisions that sometimes are then fed back to the transactional areas, and often actually they are. But so how do you? So let's not call it data. Let's call it analytics, data and analytics
or a data platform.
Right?
So it frankly it has to have two capabilities, Paulo.
Yeah.
I think it has to be able to store data and it has to be able to compute on that data. And both of these things have to be done reliably and in today's world at large scales. And these are the two fundamental things, right? And it sounds trivial, right? But it's actually not that trivial, right? Because the storing data can be, delivered by a file store, right? Like I don't know, a network drive, right? A bunch of hard disks, but it doesn't necessarily deliver on the compute. And on the other side, if you take, a traditional database or something like that, it introduces way too many constraints, right? So if you want to expand the definition, it's storing any kind of data at scale and provide computational capabilities on that. And if you want to expand it even further, then you have to say and do it in a reliable and compliant fashion. And then, when you add this additional thing, right, you basically realize, well, I have to have very good access management and security capabilities around it. But once you have this kind of total freedom of computation and storage that is delivered in a secure and well access managed fashion, you're kind of there. What does it mean practically, right? Like, and this is where we get to the selection. Practically, it means you have to choose whether you're going to deliver these capabilities on your own, like building it together from the pieces that you can buy on the market. Go to AWS and set up your data lake, right, or S3 or Athena or RDS and things like this, and kind of put it all together to achieve the security and compliance plus the technical capability to process information. or do you go and buy something a little bit, more ready-made from the market? And my personal experience here is that it makes more sense to build it on your own to fit into the needs of your organization. But it is only realistic if your organization has very heavy engineering DNA. If it doesn't have an engineering DNA, it might look good on paper that you build it yourself, but in reality, you're going to be at the mercy of vendors and consultants anyway, in which case you probably could have bought something to some extent prefabricated, from the market, right? And there are a couple of prefabricated solutions out there that still deliver on a lot of these dimensions. They may be slightly proprietary, although not by much. And that's a little bit kind of the journey we've been on, right? We've built certain things on our own, then realized that not building some big construct is not in our DNA. Working with inspired, enlightened vendors who have it in their DNA is easier for us, right? But then I know also the reverse is true. You can go to a highly, and I'm not even talking about software engineering, but just a company with an engineering mindset could be like you're in Germany, right? So there are plenty of big industrial companies out there, right? Like people with the right engineering mindset can build software as well as heavy machinery and manufacturing plants. The same kind of phenomena are kind of at play there, right? So I think that an industrial conglomerate still has a much bigger fighting chance of building a good software for themselves than a financial company, to be very honest, right? So that's a little bit how we look at this, and one should not shy away, I think, from working with good partners, right? That's probably one of the biggest learnings that we've had, right? If you choose the right partners with the right technology, right, you can avoid taking a lot of risk that you didn't even realize that you will face.
Okay. So sticking a bit to the tech platform. So in that capability, so storing the data and the different types of data, right? So what are the sort of the types of, let's call them different types of databases or types of data storage options that such a platform should have these days, right? I'm thinking from the top of my head, like classic tabular data, so relational data, and documents like text documents, but then pictures and video, or time series, whatever. I mean, there's so many types of data these days. Is it all the same? Does such a platform need to have different types of databases, pods for this kind of data? How does that work?
So I think we've on our journey, we've learned that on the level of pure storage, right, that is secure and uniformly managed from the point of access, right? I think there, one platform, one capability is enough, right? You can, and think of it essentially as, some sort of form of cloud storage, right? It can be S3, can be Azure Blob Storage, right? Both of them are quite equivalent. Your data platform, your target data platform simply has to have one of these, right? And it has to have a single consistent access management and security on top of that. And that already solves 60 to 70% of your problems, right? Whether it's the scalability, the elasticity, or security and compliance problems. You can solve them on that layer. You don't need to go anywhere else. You can solve all of them on that layer. And in most cases, capabilities to solve your problems are already coming with that layer, right? Whether it will be, AD policies in Azure, or whether it will be the IAM policies in AWS, right? Like you are able to piece together a very, very good construct, right? A very good foundational layer. Now, on that foundational layer, you have to have the processing layer and the serving layer. And these two are, this is where the discussion about individual pieces of technology comes into play, right? Like in our experience, we have this extremely generic processing layer that we use a lot, right? A Swiss Army knife of processing. In our case, it's all running under Spark. We basically decided that most of our tabular data that we extract from our relational databases, as well as structured but non-tabular, so for instance, folders full of objects, right, JSON files or whatever, all of these things are extremely easy to process with Spark. But even slightly more complex things like images, right, or other things that can be processed with relative ease in parallel, they will all fit a computational paradigm that Spark offers, right? So all the heavy-duty ingestion, pre-processing, and initial stages of processing can be done in that layer in most cases. Where it gets very tricky, where we see a lot of confusion on the enterprise architecture, let's say, level, is what to do next after that. Right. And there, the selection of technology for the right purpose is important. And I have one general observation there. Do not worry about duplication of data, or even using or putting the same data into multiple serving stores for your final bits of processing, right? So if you have a Postgres or Elasticsearch or I don't know, Cosmos DB or something like that, because that is a serving store that will interact with your application the best for this last mile of data delivery or data discovery, right? And you even need to push the same information to these three constructs, because different users in different applications will look at the same information with a slightly different angle. Sure. That's absolutely fine. Okay. There's the cost of doing that is trivially low compared to the capability to learn. And I've been in a position where people have questioned, like, why do you duplicate data, replicate data, and that's not the discussion that one has to have in 2023, right? This is 3% of the cost of a solution, right? Or 4 storage. Or 5 maybe, right? Storage.
So one thing that comes to mind is bringing the data in. So the capability, this ability to bring the data in, or bringing them out to, let's say, okay, I understand you have, let's say in your case, you chose a solution from a vendor, and I think the vendor is public, so I don't think we need to be secret about it, Palantir. And it's basically it stores the data on a distributed file system, on top of which Spark works, and basically, so you need to bring the data in. How do you bring the data in? Is that should that be part of a platform or not, or is that something else? And the second question I have,
it is, yeah.
The second question I have is, or should that be part of the platform that you choose? I understand in your case it is, or should it not, right? What is the best decision here? And then in the cases where, okay, the data is on a distributed file system, well, that's not really how I need it in my reporting application, because it's not easy for me to query it for some reason. I need something else. I need whatever, Postgres, as you said, because it's easier for me to make SQL queries that are performing. So how do I bring the data then to that Postgres? And is that Postgres still part of that platform, or is that outside?
Yeah. I mean, all good questions. So to answer your first question, do we believe that the data capture, data ingestion capability should be considered part of the platform? My experience tells me yes. And there is one reason. So because what is the alternative? The alternative is the data is pushed, right, from various sources, and it just magically appears, right? In that usually means that you're not exactly sure where it came from or how it came to be. If we drive the data ingestion process from inside the data platform, we do have this additional piece of information about the data lineage within the platform. So you can, in our specific case, right, we can kind of trace the pedigree, the provenance of data from the final report all the way to the SQL query that was issued on all the source tables that were extracted from some operational systems, or maybe from some legacy data warehouse or ODS or something like that, right? That we still have in our landscape. We prefer this to a scenario where a file called atr007.dat lands, every day at 7 a.m. by some mysterious, SFTP process, right? Like that obviously in that case it requires a much more rigid, documentation outside of the data platform and so on, and rigor, which I think is difficult to maintain over long periods of time, right? So I prefer to have the ingestion capability as part of the platform, also because it allows me to steer the frequency of ingestion better. Obviously, this comes at a cost that the source system has to be prepared, to offer the data. The way we do that is we actually, to close the loop on this, we give the responsibility of sourcing the data into the platform to the owner of the source, but we give them the tools that are part of the data platform, right? So a function that owns the source has the responsibility for operating the ingestion onto the data platform as well, but not by pushing data, but by using our tools, right? So they can exactly. So it's more like there is a personal union, if you want, right? That deals with, or at least that's the model that we try to push. It doesn't always work with every team and so on, but that's the model we like.
Does that mean that you encourage that like an API-driven kind of landscape, that you can actually pull this data from APIs, or how do you encourage that?
Most of the data that we have today is still tabular, right? So it's using standards like JDBC or ODBC connections to the data.
Go directly
where it doesn't. Exactly, where it doesn't, where we have especially external sources, right? So some internet-based sources, right? These are usually going to be some form of like RESTful sources, and yeah, exactly. And we do have a capability to basically pull data or leech, or however you want to call it, right? Scrape data from those APIs in a way that is operationally sound, right, and resilient to errors. And but it's part of the same kind of strategy, right? Like we still kind of prefer that whoever maintains that relationship with this external source also engineers the pull into the data platform.
Okay.
Yeah, and then your second question, are those serving stores, right? So in our case, not all, but most of the serving stores are part of the same bigger data platform. And the reason is automation of synchronization of data, right? So when you think about this level of dumb storage that is only files and they are processed with Spark, you want to essentially you want to achieve a capability where there's like a one-click, you're one click away from having the contents of your Parquet table in your Postgres whenever this Parquet table updates. And that's what we've achieved for Elasticsearch capability, Postgres capability, and maybe one or two others. We also have like some more specific things, like a map server, for instance, that is kind of adjacent to the Postgres and so on. We prefer to have it inside of the platform because then first of all, the synchronization, right, can be done just in time whenever data refreshes. It's only whenever it's stale, and this way we reduce the cost basically, and increase the data recency. But also because we are able to apply the exact same access management to the data, right? So in our case, the exact same access management rule will apply to data, logical element of data, whether it is stored in the data lake or whether it has been mirrored to a Postgres table or whether it has been indexed into Elasticsearch, right?
Okay.
If the data is accessible by Paulo Nunes, it will be accessible by Paulo Nunes in these three places based on exactly the same one single access policy, right? If those components were outside of the data platform, we would have to replicate or mimic the access management policies, which is less trivial then, right? And it's prone to desynchronization.
Okay. So all right, so tech platform should have a capability. So you should be able to store data, should be able to compute on the data. It's very useful, from what you said, to have also capability to bring data in because of lineage, for example. You probably also are able to standardize that process of bringing the data, those data pipelines. Let's call them that way. And then it's also useful to have the serving, let's say the serving stores, the whatever, the data marts, or the equivalent for different types of data, is also useful to have them as part of the same ecosystem for many reasons. Among them, well, governance is probably the most, but also you talked about performance. And so how fast that happens, right? How fast the data can be there available. So the question is then, that seems like a very complete set of capabilities in one single platform. How many platforms are like that in the market that have those capabilities? And maybe we could just briefly talk about a few examples of other. So we understand that Palantir Foundry is the product that you and your company use, but are there other products in the market that also have all these capabilities? And I have a follow-up question, but I don't ask it yet.
So of course, so there are at least a couple of other, alternatives. Like, yes, you're right. Like, we work with Foundry, and it serves our purpose well. We've been doing it for a good couple of years now. But being able to put together something similar by using individual services from AWS or from Azure is also feasible. No question about that. It does not come as prepackaged, right? So there is quite a bit of work where you have to still configure it exactly to your liking, right? And like, I mean, you do this every day, right? But setting up a larger data lake structure on Azure, requires you to define everything from networking policies, right, and creating the network, to instantiating the endpoints, to applying ACLs, right, to creating Databricks workspaces and so on. It's a major undertaking.
It's a major
right?
project.
Exactly, right? So all the base capabilities are definitely there, and basically with that comes infinite flexibility, right? But obviously, as the joke goes, right, also enough rope, to potentially hang yourself 10 times over, right? So, but that's what it is, right? It comes with infinite flexibility, no question. You will almost never run into a constraint that you cannot overcome, right? But you have to know what you're doing. Similarly with AWS, and you've seen on both in both the Microsoft and AWS worlds, you have this somewhat prepackaged proposition. I think the most recent, branding name from Microsoft is Fabric, right, or something like that, and AWS outright just had like a data lake builder or something of that sort, right?
Yeah, they are moving closer to more ready to go data platforms.
And then there are a couple of these niche vendors that usually they somehow occupy 60-70% of the whole stack, right? Like, I don't want to name them because there are very many, right? But many of those coming from the reporting world, or from no code analysis world and so on. And there are some variations of Spark, Hadoop enabled, data environments. And I think you're able to put together an architecture like that with most of them. And I've spoken to my peers and other large companies, and some of them have been very successful building or putting together things like that on their own. Others have gone with one of those vendors and selected them. As I said at the beginning of the podcast, I don't believe that it necessarily matters much to the final outcome, but it matters which platform you select. What is important is that you stick to your choices, right? Consequently, right? So the consequence, right, and your choices matters a lot. And it might cost you if you want to have much more flexibility, right? So if you decide to go on a path where you want to build a lot of things on your own, it will just cost you more, right? That's I think a fact, right? Is it going to end up being a much bigger beast to maintain? It's going to be much more expensive and so on. Frankly, I don't think anybody in the world today has answered to that, because nobody is more than 5-6 years into a journey like this just yet, right? But that's a little bit where we are.
Okay. So one thing that I wanted to ask you, since you mentioned how can you measure? So we talked about until now about data strategy and how do you choose the technology platform, the do's and don'ts. We talked about how can that help an organization, and you mentioned before that one of the ways you can measure how good is your data strategy, it's actually in how fast you can move things. And that means, for example, going to the insurance space, how fast can you bring a new product to the market, right? Now, do you see a difference there, right? We used to work together, right? So that's how we met each other. And we went a bit separate ways in the last 7 years, I think. And something has shifted there. Something has happened. So do you see a difference, right? How fast could, in your experience, a company launch a product, and how fast can it do it now? Can it do it much faster now because of this transformation that you worked on?
I think yeah, the question is really good. I think we have a couple of examples, and like if you go to my employer's website, there are some interesting like digital service propositions.
Yeah.
This has definitely accelerated. Whether it has directly accelerated because of the data platform or analytics strategy or data strategy, I would say partially, but I think it was not directly related one to the other. This was the fact that we were able to launch certain digital value proposition faster has more to do with our general overhaul of how we build applications, right? So it's more the journey to the cloud, right? And the modularization and reliance on software as service or platform as service, right? That allows us to speed up. If I were to be completely honest. Where I believe the data platform has significantly helped is in demonstrating how quickly we can inject technology into decision support processes where before projects like these would have been major undertakings that are 6, 9, 12 months. I have now seen multiple examples where we walk into let's say a proverbial team that operates only on Excel and paper, and they end up having a fully kind of platform supported workflow or set of workflows within 6 to 8 weeks. That is something I have not seen much, neither 7 years ago when we were together, nor 10 years ago, nor 15 years ago, right? So we had a couple of examples like this, and this basically there is a very simple, there is no magic there, right? This comes from the fact that data that this team needs is already onboarded into the data platform, that the application building components are pre-made, right? So there's basically prefabs that are ready. And that the kind of data processing components that are required are part of the data platform as well, right? So basically you walk into when you build an application from ground up, we now walk into a room or to a house that is already 70% finished.
Right.
And we just worked on the remaining 30%, right? So instead of having a 3 or 6 month project, we have a 4 to 8 week project, right? Like literally that's where we are, right? So, and that I believe is a big change.
Yeah, so I hear different things here. So one that you mentioned, okay, even if the data, I believe that also even if the data is not onboarded yet in the platform, it's also much faster to do it now than it used to be before.
Of course,
because
yeah,
I remember,
that's true. Yeah,
I remember like if you had to build ETLs and bring the data into a data warehouse, create data marts and all that, that was not as fast as now. Now that's one thing. Then building the processing and the analytics workloads, the transformation is also something that became easier and faster once the data is in. That I also see that. But there's another important component that you mentioned, is that the pre-built components, the sort of low code or the low or no code aspect to building analytics applications, right? That has also evolved in the last years, and that emerged. This makes the whole process of building a reporting application or an analytics application that supports decisions much faster, right? And brings that from 6 months or 1 year to 6 weeks or 8 weeks. would that be a good summary?
I think so, and maybe just on this last aspect, that the reason why when you think about it, it's not just really about templatizing things, but basically our data platforms, output is data. Our data is objects, right? It's basically an object layer that is ready to go to be used by an application, right? So if you need to build this final UI, that's really what you're doing, right? Like all your low level and middleware is already there, right? It's prefabbed for you. So that's how we should be thinking about this, right? Like there is also a bit of an aspect that you have low or no code UI, let's say, builders, right? Wizards, creators, and so on. But I would say that isn't even the biggest thing, right? Because you still need to do work, right? Like no matter whether you write code or you click, some buttons and so on, like you end up doing a lot of work, right? And that doesn't go away. But not having to worry about provisioning your data, structuring it for your application, right? Usually, making some exclusive decisions, right? For your application rather than maybe for multiple applications, right? These things is where these are the things where we see a big, benefit, right? Of doing it usually once centrally in a standardized way.
All right. Yeah, I also see that that's happening. So I had one more question before we close. Actually, two. One is something that I mentioned at the beginning when we're doing the briefing. For a middle, so you work for a large company, a global large company. Now there is this tissue of medium companies, let's say, that let's say from 500 to 1,000 or 2,000 employees. What would be your advice to them in terms of going about a data strategy and selecting a data platform? Because, for example, it seems that something like Palantir Foundry is a good fit for large enterprise. It's a costly, let's say that's the Rolls Royce of. I didn't want to mention brands, but I just ended up doing it. It's the Rolls Royce of data platforms.
I understand where you're coming from.
What does it like a medium company? How does a medium company need to think about this? And what would be your advice in order to should they build, should they buy, and if they buy, what should they buy? What is the criteria? Not the product, but the criteria to choose a product.
I don't know if I have a single answer to that. I think what I would say is that the less resources you have, the less you should succumb to temptation to build things just for you, right? Like your medium-sized company is not unique, I think, in terms of the problems, right, that it faces. So I think there is a strong rationale to assume that a pre-made data platform from a medium-sized vendor might actually be a more economical choice than trying to build something on your own. You may initially think that building something on your own is cheaper because you only look at the cost of the materials rather than at the cost of the assembly, right? So if there is one thing that I would recommend here is to be very honest about assessing the cost of assembly, right? And second guess anybody who comes up with a recommendation, right? If the cost of assembly is less than 80% of your project cost, then it's probably wrong. That's really how I look at it.
In other words, you probably shouldn't build it yourself.
I don't think so. Yeah, exactly. I don't think so, right? Because you're going to fail. You're going to fail, or you're going to misestimate the cost of assembly.
Yeah. So don't build it yourself. Don't underestimate the cost of building and maintaining, right? Because it's also maintaining and the total cost of having that. So I tend to have the same opinion. So I have one last question, and it's around this hot topic, the hottest topic in the last 6 months, called ChatGPT. how do you see ChatGPT, large language models in general, and ChatGPT in particular? Do you see that changing the way people approach data strategy and approach this kind of topics?
I do, but I don't fixate on large language models as a specific category. So a lot of my, hobby, or let's call this like informal research, has always been in kind of like intelligent agents, like whether you look at, automation industry or in computer games. And ChatGPT or GPT kind of technology to build large language models is just one way of building intelligent agents, right? And probably, from what we see, an extremely efficient way of building intelligent agents, right? Because you essentially can, program them in English, right, so to speak. Or at least that's the promise, right? The promise is that you are able to achieve a lot of semi-intelligent output, right, behavior by literally just dictating the task, right? A big mistake that a lot of people make is thinking that this is a knowledge repository that you should query, right? And kind of put it on the same mental level as Google or Wikipedia, right? That's nonsense. That's not what it is, right? No. It just happens to be trained on these sources, right? So it can sometimes give you accurate or semi-accurate answers. But in reality, from what we've seen, right, it's more this the ability to reason on a piece of input, right, that is actually quite interesting, right? So,
right,
feeding it a document and saying, can you please summarize it for me? Or feeding a document and saying, hey, do you believe that, based on that contract, I should, pay out an insurance claim, right, or something like that. Right. And this is where we see the ability to create these intelligent agents.
You go, and, like, if you get a piece of reliable information and give it to it and say, well, using this piece of reliable information, give me something useful, right? You can't rely on it for accurate information, but you can use it to help you distill, process.
That's right.
Reliable information.
So exactly. So coming back to what we were discussing, right? Data pipelines, right, and open data flow, and in a big organization, right? There is probably 1,001 points during a flow of a nugget of information through an organization where you can enrich it, right, and you can make some decisions, right, based on that. And that's exactly where I currently see, a big benefit, right, of these types of intelligent agents, right? You can really relatively quickly train them to enrich information at multiple steps along the way, and eliminate the need of having a human in the loop everywhere, right? Or reduce the amount of human in the loop, right? And kind of bring us to a level where a lot of business processes are very much exception handling processes than other way around. Like a little bit like, when you look at IT today, you know that, right? Like nobody pushes bytes through a network. Everybody monitors whether the network runs by itself, right? And like you want to achieve this level of cohesion and automation on this much higher business process and business information flow level, right? So having intelligent automatons, right, in that process, right, whether they are trained using, LLMs or some similar technologies, is definitely where I see a massive amount of opportunity. Now, are there opportunities beyond that, right? So can you train your own models based on your own information, fine tune, and create, even higher order, automation and behaviors? Of course, right? We're going to get there eventually, right? But if you ask me today, what is going to be the focus for the next 2, 3, 4 years, I believe it's still going to be implementation of those models in relatively narrow, self-confined tasks, where the output is rather preordained. So like, asking a single question, expecting a single output, and so on. Like, I don't believe that we are at a stage where we can breed an agent that can just plan a complex set of activities that is that mimics a complex human behavior that is 20, 30 steps, and that anybody will be sold on the accuracy of that behavior, right? Like we will not be able to ensure that it will be accurate or reliable, to the extent, right? It's a little bit like with self-driving Tesla kind of problem, right? Like we're almost there, but we're not completely there, and it's gonna be in beta for another 5 years.
All right.
That's a little bit how I look at this, which is not to say that it's not extremely compelling, right? When you see the demos and what it can do, it's mind blowing, right? To some extent.
It is. It is. It works like magic.
Yeah.
It's quite amazing. And yesterday I was talking to a customer of ours, and we were discussing like a case use case for exactly for that, for applying a large language model or GPT to. And the case was very interesting. It was about around data processing. So basically, there's lots of legacy sources of information, knowledge bases, old knowledge bases with various levels of quality, let's say, and also quite heterogeneous. So there's like, let's say, handful of different pots of information. Well, this is a customer service kind of case where and the questions can be quite technical coming from the customer, and the idea was to use this kind of model to sort of when you're bringing this data from these different pots into one single place that actually can be used to answer customer questions, that you use a large language model to help do some work on the quality of that information actually, and to not only to summarize it but also to extract relevant things, to bring it to a style of communication writing that is actually more or less kind of consistent, right? That it does, because these things were written by different people. So replacing a bit of editorial kind of work that a person would need to, that people, actual humans would need to do. And then you still have that in the end, a sort of a sign up from the communications team. Okay, this is a good piece of, this would be a good answer, a good piece of answer. But that like transformation of the data coming from the original is actually assisted by this large language models. That was quite an interesting conversation. And so it's kind of a data processing step that is assisted by a large language model, and this is it's quite powerful because it also helps kind of organizing the data in the right way and bringing it to quality, to the quality that you need, because data quality, as you probably know even better than me, is also one of the things that you need, right? You can have great data lake, but if your data doesn't have quality, we haven't had the chance to talk about that, about quality, and this would be a topic for another day. But yeah, I can see this kind of intelligent agents or this kind of assistance in different steps of the way here and there. This can be done already now, even without having to train your own model from scratch, or without having to fine-tune a model like that with your data, but you can just use it as something that understands language and can actually be a bridge between two things. And so that's really exciting. And alone that is a big, I think it's going to be a big step. Yeah.
I agree. I mean, it's. I mean, I'm sure that we will have to tackle this right in our journey, and obviously, things here pop up here and there. But I currently do see it more as a yet another step, in your longer, transforms or pipelines, rather than something completely, but entirely new. I think we're gonna get to a point where it is something significantly different, but I think we're still not at that state. I mean, your example is actually a good example. Yes, it's a very complex task to smoothen style of a piece of text, but at the same time, it's just a simple task, right? It's a simple task in the sense that it has a very definite input and a very definite output, right? Difficulties maybe in measuring the quality of that, right? But it's not difficult to confine it to only one step, right, in your process. Right. People who think that these language models can be used for planning of complex tasks, right, are in my opinion reaching a little bit too far currently, right? Which is not to say that that LLM or GPT maybe type of technology is not going to be one of the tools to build complex planners.
Yeah,
right?
definitely.
Which is but it's a little bit of a different different topic, right?
Yeah, definitely. Is there
All right.
anything else? Is there anything else you'd like to add, Lucas?
No, I don't think so. I think it's were actually quite interesting and challenging questions. I in some way, I always envy like people like you who work with multiple companies to see the kind of breadth of problems that are out there, right? I usually have to focus on the depth of very few problems. So it's interesting, to also be challenged and to talk a little bit to somebody, and especially since also a lot of the world in which I currently operate, since we met there.
Yeah, and big changes. I mean, I see a big change looking back 7 years and where your company was and where it is now. It's you've done a great job there, and I think that even though that's hard to measure, I still think that it's going to help the company in the future really become data driven. So this is I also have a lot of admiration for your work, and I believe that I've been at both sides as a company in a company doing deep work and getting busy with the details, also owning something end to end, right? That's that's something in that position you learn a lot, right? Now being on that other side of the service provider, you can see what the companies are doing, but you actually get to value people like you more that actually own things end to end and know what it means to build something and then to run it afterwards. And these conversations are gold. So thank you for being here, for coming, Lucas.
Thanks for the invitation, and
always a pleasure.
Let's do
to
it
talk
again
to you.
sometime.
Let's do it again in the future soon. And
All right.
have a great day. Thank you.
Yeah, you too. Bye-bye.
Thank you for watching our episode, this episode of our podcast. Don't forget to give us a like if you're watching on YouTube. Subscribe to our channel, or you can also listen to our podcast on Apple Podcast, Spotify, and Google Podcasts. Thank you very much for listening and watching.